Electric charge. In this lesson, we are going to learn the electric charges. Today, we are going to learn about different types of electric charges. Nowadays, we use clothes made from artificial yarn like woolen or polyester. They are durable and convenient to use. You might have seen that when you take off woolen or polyester clothes, your hair stands on the ends. If you take off these clothes in the dark, you see even a spark and hear a crackling sound. Activity. Spread some tiny pieces of paper on a table. Bring a plastic ruler and plastic comb near them. We do not see any effect. Now, rub one end of the ruler and the plastic comb with a cloth and bring that end near the papers. They are pulled towards the ruler and the plastic comb. Generally, if we rub a plastic ruler or a plastic comb on a cloth, an electric charge develops on them. It is because of the charge that the paper scraps are attracted to the comb or the ruler. As this charge remains still on an object, it is called a static electric charge. Activity. Blow up a rubber balloon. Rub it on your clothes and hold it close to a wall. When the balloon is rubbed against the cloth, it is charged and it sticks to the wall. Formation. The sparks that the Greeks knew about. The ancient Greeks knew as early as 600 BC that when amber is a kind of resin, was rubbed with fur, it attracted light objects such as hair. Static electric charge is of two types: positive electric charge and negative electric charge. When a glass rod is rubbed on silk cloth, the rod develops a positive charge. When an ebonite rod is rubbed on woolen cloth, a negative charge develops on the rod. Activity. Take two straws we use for sipping cold drinks. Push a pin through the center of one straw and stick it into the top of a wooden table. Make sure the straw can turn freely around the pin. Now, rub the other straw on a cloth. Bring that straw near the one fixed on the table. The two ends are attracted to each other. This shows that an object with charge attracts an object without any charge. Now, rub one end of both the straws on cloth and bring them near each other. The two ends move away from each other. What is the reason for this? The material of the straw was rubbed on the same substance, that is cloth. Electric charge of the same kind was developed on each. Similar charges repel each other. Rub an ebonite rod on woolen cloth. Then, hang the charged ebonite rod on a stand. Bring another ebonite rod, charged in the same way, near it. We see that they repel one another. Now, bring a glass rod charged on the silk cloth near it. The two rods will attract each. From this, we come to know that like charges. Example, the two negative charges on ebonite rod repel each other, and two unlike charges. Example, the positive charge on the glass rod and the negative charge on the ebonite rod attract each other. Transfer and induction of electric charge. You know how tug-of-war is played. There are equal number of players on either sides. The team which has stronger players pull over the weaker team. What would happen if the players all had equal strength? Both teams will be equally strong and neither side will win. Now what would happen if a player of one team crosses over to the other side? The first team is one player short. The second has an extra player. The latter team becomes stronger. The teams are not balanced anymore. This is how minute particles go from one substance to another and electric charge is created. Why does rubbing one substance on another create charge? Every substance is made up of matter. The smallest particle of matter is called an atom. Every atom contains smaller particles with either positive or negative charges. As the number of positively and negatively charged particles in an atom is equal, they neutralize each other. As a result, the atom has no charge. Electric charge is created only when specific substances are rubbed together. On rubbing, some negative particles are transferred from one substance to the other, and the latter develops a negative charge. Silk rubbed on glass. The substance, glass, from which particles are removed loses the negative charge. Hence, it develops a positive charge. The minute particles with a negative charge are called electrons. What happens if a body with no charge is brought near the another body with positive charge? In the uncharged body, the number of positive charges and negative charges is equal. The negative particles in it get attracted towards the positively charged body. What is the effect of this? The negative particles collect at the end of the body, which is nearest to the positively charged body, while the positive particles collect at the opposite end. Thus, an opposite charge develops on the end nearest the charged body, and a like charged at the furthest end. This action of electric charges, which takes place when two bodies are brought close together, is called electrical induction. What happens if the charged body is removed? The charges at the two ends of the other body mixes together again, and no charge will remain on it. It means that an induced charge exists only so long as the charged body is placed nearby. We can also see that the attraction between a charged and an uncharged body is due to the induced opposite charge. Transfer of charge. Activity. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paperclip could be inserted. Open out the paperclip. Cut two strips of aluminium foil about 4 cm into 1 cm each. Hang them on the paperclip as shown. Insert the paperclip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch it with the end of the paperclip. The aluminium foil strips receive the same charge from the charged refill through the paperclip. Remember that metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is known as electroscope. When lightning strikes, tall buildings particularly are at greater risk. To prevent any damage due to lightning, a lightning conductor is fitted at the top of each building. Lightning conductor has a point shape and is made up of copper. The other end of this strip is buried directly in the ground. When lightning occurs, it is attracted to the pointed lightning conductor and from there flows directly into the ground. Thus, any damage to the building due to lightning is prevented. Summary. Electric charges are of two types, positive and negative. Like charges repel each other, while unlike charges attract each other. Due to induction, an unlike charge